So welcome back to the channel. Today we are going to discuss about the different periodic properties, how it varies in a group and in the periods. We'll see it is gradually increasing or it is gradually decreasing. There are different periodic properties such as atomic size, this electron affinity, electron negativity, all of this. Okay. Now first we'll start with the atomic size, right? What is called atomic size? This is the distance between the center of nucleus of an atom and its outermost shell. If you imagine this is an atom, this is the nucleus and this is the outermost shell, the distance between this, it is called the atomic radius. Okay, the atomic radius unit, it is expressed as angstrom unit. Now we'll see what are the factor affects the atomic size. First is that number of cell. Okay, so if the number of cell increases, the atomic size it will increases. Why? Because if you see in case of lithium, it has the electronic configuration of 2 and 1. That means 2 electron it will be in the first cell and the another electron it will be in the last orbital. So the distance between the nucleus and the outermost orbital, let's say it is R1. Now in case of sodium, the electronic configuration is 281. So 2 electron it will be in the first orbital, next orbital 8 electron, and in the last orbital it is 1 electron. So the distance is R2. Now you can see in case of lithium we have 2 orbital, in case of sodium we have 3 orbital. So obviously as it has more orbital, the distance between the nucleus and in the last orbital it will increase. That is why R2 it will always greater than R1. Okay, this is the first like a factor which can affect the atomic size. The second factor is that nuclear charge. What is called nuclear charge? Nuclear charge of an atom is the positive charge on the nucleus of an atom. So it is equivalent to the atomic number of an element. Okay, so nuclear charge, how it will affect? This is basically the attractive force between nucleus and its electron is called the nuclear charge. That means more and more electrons are added in a period, in elements here. Let's say this lithium, beryllium and boron. Here you can see their electronic configuration changing from 2,1 to 2,2 and 2,3. So more and more number of electrons are adding, right? So what will happen if more and more number of electrons will be added? They will the attraction force will be more, then the atomic size it will decrease, right? So if the nuclear charge increases, the atomic size will decrease, right? Now we'll see how it will affect across a period from left to right. Let's say here it is present, the elements is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. This is their electronic configuration: 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6, 2, 7, 2, 8. Now we know that there are two factors. First is the number of cells and second is that nuclear charge. Here if you see all the elements as the number of cell is 2 only, right? Number of cells equal to 2. So this factor is constant for all the element across a period. Now the second factor is that nuclear charge. Nuclear charge means more and more number of electrons are adding over in the last orbital. There will be more and more attractive force with the nucleus, then it will the size will decrease, right? So in this case you see, in this case see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, as they have these things, more and more attraction, more and more nuclear charges, so their atomic size gradually decreases. Here you see the atomic radius 1.55, then 1.12, 0.88 and this 0.77, 0.70, 0.64. These are the things. So what we are getting is that basically atomic size decreases from left to right, right? So this is what we are getting. See, atomic size decreases from left to right. Okay, now we are going to see what will happen across a if you are going across a if you are going down a groove. Okay, let's say in the case of these things, lithium, sodium, potassium, rubidium and cesium. Then we'll write down their electronic configuration 2 1 2 8 1 2 8 8 1. Then for rubidium it is 2 8 18 8 1, and then for cesium. Now what will happen here? What we are getting is that first point is that number of cell, right? Two factor it affects. One is the number of cell, another one is the nuclear charge. In so the first factor is the number of cells. See, every cases the number of cells are increasing, so the atomic size should increase. Nuclear charge also increasing, so the atomic size should decrease. Now one factor is increasing, one factor is decreasing, so who will dominate here? That is what we have to see. As the number of cells increasing is the dominating factor, because here you see, so although number of electrons are increasing, but number of cells are increasing, na? So here you see this is smaller one. If you have the 2 cell, if you have the 3 cell, how it will looks like? If you have the 4 cell, it will look more bigger and bigger, right? So the atomic size basically it will increase whenever you are going down a groove, right? So if we are comparing with this fluorine, chlorine and bromine, iodine, what will happen? So fluorine, chlorine, bromine, iodine, so atomic size will increases for iodine, then bromine, then chlorine, and then for fluorine. Okay, now this is the things final message from here. The atomic size decreases left to right of a period and increases down a group, right? This is what it is for atomic size.